Right, here we go. Climate change. Right, let's start off by making an important point. This has absolutely nothing to do with the ozone layer. Don't talk about the ozone layer or the depletion of the ozone layer. It's got nothing to do with it, okay? This is to do with greenhouse gases. Now, our most significant greenhouse gases are water, believe it or not, and CO2, carbon dioxide, okay? These are the most significant greenhouse gases. We've got some less significant or lower impact gases, and those are methane and nitrogen oxides. We put that X there because it can mean 2, 3, 4, it could be a range of different things. So we put nitrogen oxides, and these have less impact. But they do still have a greenhouse effect, if you like. Okay, righty-ho. So the significance is dependent on two things. The first one is the gas's ability to absorb long-wave radiation. The second factor is its concentration in the environment. And that will determine the impact. So if you don't have very much, it won't have a big impact. If it can't absorb a lot of long-wave radiation, even if it's at a high concentration, then it won't have much impact. It has to have a combination of the two. Okay, so when we're talking about climate change, what's happening is the Earth, here you go, emits long-wave radiation in the form of heat. The greenhouse gases, which I'm drawing beautifully here, they absorb the heat, or the long wave radiation. So what that results in is high temperatures, so increased global temperature. Just turn that to a bit of a globe. So you can see that didn't turn out too well. Anyway, you get the point. It's a global temperature, so you're increasing these global temperatures. And also the climate patterns are influenced all by the concentration of the greenhouse gases. Okay, so over time, we've seen, so this is time, over time, that the CO2 levels since, say, about 200 years ago, where there was a big event, the Industrial Revolution, okay, and what happened was It's a bit jaggedy, but it goes up, okay, since 200 million years ago, and then recently much more. Okay, and there's a correlation between the CO2 levels and, if I can find a different pen, average global temperatures. And there appears to be a correlation between the two. Okay. Now, in most recent years, there has been an increase, a massive increase, in both, and in temp. And this is because what we're doing is burning fossil fuels. Whether that's to create electricity or to drive cars or transport or any of those kind of things, we are burning more fossil fuels, which are releasing the carbon dioxide that's been trapped inside of complex carbon compounds for thousands and thousands of years, and we're releasing them all in one go by burning fossil fuels. So this is creating this this increase towards the end here. Okay, now this increase in carbon dioxide in the atmosphere is also having another impact, and that's on the oceans. Okay, so the amount of CO2 it dissolves in the air is massive, so it dissolves into the sea. Okay, so as I was saying, carbon dioxide dissolves into the ocean. Now, inside the ocean, there are things like coral reefs. Okay, coral reefs are made of, we know that they're another place that carbon dioxide can become trapped, a reservoir, because their bodies contain calcium carbonate. Okay, they're made up of that, and then they can go on to make limestone, as we saw when we were looking at the carbon cycle. However, when the carbon dioxide dissolves into the water, so you get high levels of carbon dioxide, dissolved carbon dioxide, and also in the form of hydrogen carbonate ions. Okay, so those two things cause the water to become acidic, so they lower the pH, and the impact that has on the coral reef is extreme. Okay, so this is damaging. Due to the acidity. Okay, so there's some key things there. Now, what you need to be able to do, one of the skills for this section is to determine from evidence, is this really caused by human activity? It may seem like a simple point, but there's some evidence to suggest that the fluctuations in carbon dioxide levels have been happening for thousands and thousands, millions of years, and actually humans have little to do with this. But there's evidence to suggest the other way. What you need to be able to do is to evaluate, which means to look at both sides. And to carefully pick out the evidence or use the evidence to reach a conclusion. Okay, you can't disregard evidence, but making it clear why you feel one is more convincing than the other. Okie dokie, or whether you think it's a complete balance, that's up to you, what other evidence you need to find out. So here we go, that is climate change. Let's see if I can make it in the whole screen. Okay, So that's the mind map for climate change there. Right, thanks.